Hello, let's do the notes for 2D out of Unit 7, Angles of Elevation and Depression. This last section that we're going to work on is applications of the different types of skills that you've learned, how to find a missing side, how to find a missing angle. This piece talks about two different ways to figure out what an angle is going to be, and they're called elevation and depression. So there's two different scenarios here of what I've got some pictures of. So if this is the ground, okay, this line up here is parallel to it. If something is looking up, maybe it's looking up to this airplane, maybe it's looking up to the sun, to the top of a mountain, could be looking up at a lot of things. That is called the angle of elevation. If I'm up in an airplane, or if I'm on top of a building or a mountain and I'm looking straight out, but then I look down at this person, that is called the angle of depression. Okay, so it always starts looking straight out. If I look down, it's an angle of depression. If I'm here and I look up, that is an angle of elevation. Now, if you remember from when we did parallel lines, so if this line up here, AB, is parallel to CD, then these two angles, angle of depression and angle of elevation, are going to be equal. They are alternate interior angles. They're going to be equal. Another way to think of angle of elevation and depression, here I got SpongeBob looking straight ahead. So if he has to look up at Patrick, then that's an angle of elevation there. If he's looking straight across and then he looks down at Squidward, I believe his name is, that's an angle of depression. Okay, so they all start out looking straight ahead. So let's take a look at how we would do these. So you'll see here, we've got the problem, it's got a bunch of information. We're going to take that information and put it on a picture. Then we're going to take that picture and help us write an equation, and then we're going to solve it. All right, so I've just drawn some generic right triangles in here. And let's just read the whole thing first so we know what's up and down and what's on the ground and what's diagonal. A person is standing on the ground at a point 78 feet from the base of a building. The angle of elevation to the top of the building is 57 degrees. To the nearest foot, how high is the building? So when I think about buildings, I'm thinking about something tall. So this right here, I'm going to say is the building. Okay. The person is standing on the ground. This is the ground. This is the person. Now we could get a little picky on, is it a angle of elevation if I'm looking from my feet? Yes, it is. Okay. Anything that is going to change in direction going up, that's an angle of elevation. So a person standing on the ground at a point 78 feet from the base of the building. So from here to here is 78. The angle of elevation to the top of the building, so from here to here is the angle of elevation, that is 57 degrees. Now where's our x going to be? To the nearest foot, how high is the building? There's my x. Okay, once I have all that info, then I have to look and see what I'm trying to find. So this is missing a side. So I'm going to do my ratios, figure out which one I need. Here's the angle that I'm talking about. So I have the opposite and the adjacent. So I'm going to use tan 57 degrees equals opposite over adjacent. Okay, so x is on the top, so I'm going to multiply 78 times tan of 57. You know what, I'm just going to write that here so people don't forget what to do. And when I do that, I get x equals 120 point something, but it says to the nearest foot, so I'm just going to leave it 120 feet. If it does not say specifically how it wants the answer, then we are going to round to the nearest tenth. All right, let's do this one. The sun shines on a flagpole, causing the shadow to be cast on the ground. Ground, shadow, flagpole, straight up and down. The distance from the base of the pole to the tip of the shadow is 49. So we said this is our pole, and this is our shadow. From the base of the pole to the tip of the shadow is 49. The sun's rays make an angle of 38 degrees with the ground. Well, there's the rays, and here's my ground, so that angle right there is 38. How tall is the flagpole? Here's my X. This is also going to be a tangent. I have opposite and adjacent. This angle is 38 degrees, opposite over adjacent. When I multiply that out, I get 38.3 feet. Okay, we're going to stop there, and then we'll get to the other angles in the next part.